All right, here we are on day 2 for graphing. Day 1, we talked about amplitude, which was the number in front of the trig value. Today we are going to add in another number, but this one's going to touch the angle and refer to it as b, but we're going to know it as the frequency. Now, in terms of transformations, frequency is going to be your horizontal stretch and compress, so your graphs are going to look wider or narrower. But in terms of a trig graph, a frequency means how often something happens. So frequency is how many full cycles of a sine or cosine graph you will get by 2 pi. So how many cycles by 2 pi. Now remember, a full cycle of sine is a hill and a trough. A full cycle of cosine is a complete V. So the frequency tells you how many cycles you will get by the time you reach 2 pi. 2 pi was our standard period yesterday. That's how long it took to finish all of our graphs because we weren't messing with the frequency. If you have one graph, it finishes by 2 pi. If you have more than one cycle, your period is going to change. So if you're going to try to fit 3 sines into a 2 pi, then that means the period, how long it takes to finish one of them, will be shorter. Okay? So the period is how long it takes to finish one cycle. Talked about that in the last lesson a little bit. How long it takes to finish one cycle is known as a period. How many cycles you can fit into 2 pi is called the frequency. So these ones are standard graphs that we were looking at in the previous lesson. What is the frequency? The number touching the x. The frequency is 1. That means I will have one hill and trough by the time I reach 2 pi, meaning that the period for a sine graph without any bells and whistles is 2 pi. Frequency for the cosine graph is 1 because that's the number touching the angle. And that means the period for a standard cosine graph with no bells and whistles is 2 pi. I will get one full V from 0 to 2 pi. But now if you start messing around with the frequency, you have to adjust the period because it will end sometime other than 2 pi. And that formula is 2 pi divided by the frequency. So you're going to take the normal period and divide it into how many ever sizes you need for how many ever cycles you're going to try to squeeze in there. Newsflash, when modeling real-world phenomena, most periodic trig functions will not have a period of 2 pi. This is kind of rare, okay? We will get to word problems eventually, and you'll see that 2 pi is probably never heard of. So we're going to take these exercises and figure out what the frequency in the periods of these graphs would be without actually graphing them. This would be a perfect 2-point question on a Regents exam. So for letter A, frequency, that's the number touching the x, which there isn't one. So the frequency is 1, making the period 2 pi divided by 1, which is just 2 pi. Nothing exciting about that, and notice I did nothing with the 3. The 3 is the amplitude. That just tells us how high the graph is going to go. It does not affect frequency and period. Letter B, the frequency, the number touching the angle is 2. That means you are going to complete 2 full cosine V's by the time you get to 2 pi. So the period is just how long it takes to finish one of them. Well, a little common sense says if you can finish 2 cycles in 2 pi, then 1 cycle is going to be in 1 pi. Well, the formula, 2 pi divided by frequency, confirms that. The 2's are going to cancel, and it will go from 0 to pi to finish 1 full V, 1 full cycle. Letter C, frequency is a half. That means I am only going to finish half of my V by the time I get to 2 pi. So if I can get half a V in 2 pi, common sense says it's going to take until 4 pi to finish it. Well, 2 pi divided by frequency tells me what my period is. 2 pi, keep it, change it, flip it, and there you go. That says 1 full cycle will take all the way to 4 pi to complete. We'll see this on a graph in a moment. All right, example 2, determine the period of each of the following. Period's 2 pi divided by frequency. So A 2 pi divided by 4. Well, 2 over 4 is a half, so we will have one full cycle by the time pi halves hits. Next one, 2 pi divided by pi thirds. Keep it, change it, flip it. The pi's are going to cancel, and you will finish a cycle by the time you get to 6. That's more like those real world problems we were talking about. And the last one, 2 pi divided by 2/3. Keep it, change it, flip it. The 2's are going to cancel, and it's going to give you 3 pi for a period. So you will finish one full sine curve, so a hill and a trough, by the time you get to 3 pi. Helpful tips for graphing. List your amplitude, your frequency, list your period, and then number 4 is critical points. So when we graphed on day 1, we graphed for pi halves, pi, 3 pi halves, and 2 pi. So after the 0, there were 4 main points that we graphed, and they lined up with the quadrantal angles. I am not going to try to show you on a video, but no matter what our labels are on the x-axis, we really still are lining up with those quadrantal angles. I don't want you to get bogged down in points. I want you to totally rely on the pattern that sine and cosine takes. And then if we have time when you come back, hopefully somebody will show you how this works. But for right now, it's pattern based, okay? But to find your critical points, what you're doing is you're taking your period, which is how long it takes to complete one cycle, and breaking it into 4 equal parts so that you can line up with the quadrantal angles, which there are 4 of. All right, so hopefully you'll catch on. We're going to do a few of them together. So for example 3, graph y equals sine 2x from negative pi to 2 pi. All right, I am going to list those 4 things on the side of my paper before I start. My amplitude, the number in front of sine, is 1. So my graph is going up to 1 and down to negative 1. Frequency, the number touching the angle, the x, which is 2. That means from the time I start at 0 until I get to 2 pi, I should see 2 full sine curves, which is 2 hills and 2 troughs. Period, how long it takes to finish one of them. It's 2 pi divided by the frequency. The 2's cancel out. And that says I will finish one full cycle by the time I reach pi. But now what I'm going to do is I'm going to find what we call critical points. I'm going to take that period and break it into 4 equal parts. So the period is pi, and I'm going to divide it by 4. So what this does is tell me how to count on the x-axis. So we are going to count by pi over 4. Okay, now we have to get all the way to 2 pi, so I'm not going to skip any lines here. So the first line is 1 pi over 4, then 2 pi over 4, then 3 pi over 4, and now this one would be 4 pi over 4. But don't the 4's cancel? So that leaves us with just 1 pi, my period. Then after 4 pi over 4, we get 5 pi over 4. Then 6 pi over 4. Then 7 pi over 4. Then 8 pi over 4, which simplifies to 2 pi. So the critical points tell us how to count. And I got to keep counting until I get up to what it says for my domain. Well, now I got to go in the negatives. So let me blow that back up. Negative 1 pi over 4. Negative 2 pi over 4. Negative 3 pi over 4, and negative 4 pi over 4 is negative pi. So I'm sorry that those numbers are kind of small and blur together, but you're counting by 1 pi over 4. All right, so from here, you need to know the pattern of these graphs. A sine graph always starts at 0, and then goes up and then down. Okay? So we're starting at 0, then we go up to the hill, 0, down to the negative, 0, up the hill, 0, down the trough, 0. Kind of make the hills and the troughs. All right, now we got to go the other way. Down the trough, 0, up to 1, back down to 0. there is our sine graph. Okay, so I am not going to demo that the critical point thing works on this video. That's just way too much. That's something that's better off in person. All right, let's do the next one. We're going to pause here for just a second. All right, so for number 4, the amplitude is 2. The frequency is 1/2 because it's in front of the x. So the period is 2 pi divided by 1/2. Keep it, change it, flip it. So we have 4 pi. And the critical points then is you take the period and divide it into 4 equal parts, which gives you pi. So that means I'm counting on my x-axis to pi. So that's going to get me to the 2 pi and the negative 2 pi. So counting by pi's, 1 pi, 2 pi, and that's as far as I go. Now since my period is 4 pi and I'm only graphing to 2 pi, I know I'm not going to see my entire cosine curve. Oh well, I'm doing what they want. Negative 1 pi, negative 2 pi. Okay, amplitude's 2, so I'm going to go, that's 2, and that's negative 2. And now we remember the pattern. Cosine graphs make V's. So we start in the air, 0, down. Kind of a curvy thing, so I only got 1/2 of my graph, but that's okay. Now go down the other side, following the pattern. So this looks like an upside down cosine, but really this is just 2 halves of different cycles of my cosine. All right, number 5. Amplitude is 4. Frequency is 3. Period 2 pi divided by 3. Critical points 2 pi thirds divided by 4. Keep it, change it, flip it. If you flip a 4, it makes a 1/4. So I get 2 pi over 12, which simplifies to pi over 6. So when I count my x-axis, I'm counting it pi over 6. It tells me to graph 1 full cycle. And I know for 1 full cycle that after 0, I only need to graph 4 more points. So I'm going to label by going 1 pi over 6, 2 pi over 6, 3 pi over 6, and 4 pi over 6. Now those of you who are inquisitive are going, wait a minute, the period is supposed to be 2 pi thirds, so I'm supposed to get done graphing at 2 pi thirds. 4 pi over 6 simplifies to 2 pi thirds, so I'm doing fine. Amplitude is 4, so we're going up to 4 and down to negative 4. And I'm doing sine. All sine graphs start at 0, hill, 0, trough, 0. There's my 1 full cycle that ends at 2 pi thirds. Example 6. Amplitude is 3. Frequency is 1/2. Period is 2 pi divided by frequency. Keep it, change it, flip it, 4 pi. Critical points, take your period and divide it into 4 parts. So that means we're counting on the x-axis by pi. All right, so my amplitude's 3. And I only have to go to 4 pi, so I can skip 1 pi, 2 pi, 3 pi, 4 pi. So that should cover me for 1 full cosine curve since my period's 4 pi. Now the negative side, negative pi, negative 2 pi. All right, cosine graphs start in the air. So there's 3, 0, -3, 0, 3. Kind of a cursive-y type V. There's your full cosine curve. Now, do the other piece on the negative side. And there's the full graph. Take time. Remember, it doesn't matter how the x-axis is labeled. It's just that each one of those critical points that you count by gets a point on your graph following the pattern that a cosine or a sine should have. Day 2 is the homework that accompanies this lesson.